of course, you can expect some more rigor over here, and then some more mathematical nuances that you would not have seen in high school. Things like, for example, these days, MVT, mean value theorem, and other some calculus things I think are mainly missed in high school. And university sometimes they're just lost in between somewhere. And then details of things like the global extremal theorem, those kinds of things get missed sometimes between high school and these as a scene that a lot of the university calculus is done in high school, which is correct, but some of these things are missed. Polar coordinates and so on and so forth. So but basically this is not much more, but still there are some differences between high school and this. 1131 is the same as 1141 is the same as 1131, but more advanced. There's more formality. There's more idea of mathematical proofs and things here that is not available in the other one. So this is a more advanced version. 1231 again, algebra, some probability of stats here. Now, probability of stats here is not much more. In fact, this is exactly what high school covers. So this seems to be a repeat of high school. Then the algebra goes a bit further here with vector spaces and the ideas of transformations. Calculus of several variables here, but 1231 is another part that is there. And now again here, this comes from the knowledge of university stuff from high school and what they did earlier. So there are some differences, but this is going now into the second multivariate calculus. Playing those kinds of things that are available here, more advanced, of course. Algebra is the same as 1231, but more advanced. So there are two levels of these courses here. The more advanced versions and the ones that they say less advanced. The more advanced ones actually just have more mathematical nuances in there as well. So, for example, this eigenvectors and eigenvalues here, Markov chain processes, you wouldn't see this in many. Again, the same idea with more material and more nuances. Tennessee one is special. This is for advanced math honors. So there's some more discrete math stuff there here with more sets functions and logic and proof. Ideas of logic and proof here, for example, about Swift tables, exhaustion, constructive proofs, those kinds of things here that you would not see in many first year courses. And more probability here. Graphs, which is again unusual in many first year courses. You wouldn't see that in many first year courses, in my opinion. Sydney, 8 of 80 here. Then they've got Bachelor of Science, and then you've got the BSc and Masters in Math Sciences, and that has a very high 8 of 98 here, and that takes 4.5 years. So that probably is a Masters combined with the Bachelor's. The units over there. Calculus in algebra is expected. And 1961 is exactly the same in material, but more regular. And there is some more extra material here in some places. 1062 is just more advanced calculus over here. So a lot of the stuff that most of us would have seen, say, for example, in the second year mathematics in our studies, is now coming down to first year level. So, for example, this multivariate calculus stuff would be second year in my days at least here. There's some more stats over here. And again, 1962 is more advanced, the same material, but more rigor, more mathematical nuances there. And there is also this special studies program they have there, which they have as they're more advanced mathematics, but they have some extra material that's covered in seminars that the students are required to go to. So these are the same as the previous versions of the math, but they've got extra topics covered in seminars that the students are required to go to. And there's another one here. This is interesting because this is actually an environmental stats unit that the students have to do if they're the maths test major here. To me, that seems a strange one to put in there. It's not non-mathematical, and as I say, I think it's a strange one. It's still there. Melbourne, they've got a Bachelor of Mathematical Sciences with an 8 of 88, and again they've got the multivariate calculus there, exponential functions, ODEs. But again, most of this is first year material that you'd find in many university courses. Then algebra, same ideas, equations, vectors, and all the rest of it, transformations, eigenvectors. Monash has Bachelor of Science with 8 of 82. We have got 4 options here as far as combinations of unit scores, which you can see some of the combinations are common It's a matter of which direction you're going to go into. So they start trying to stream students in the pure applied and so on early on. And of course, some of these need to go also with engineering students as well. But here, this analysis of changes essentially a specialist with a bit more mathematical things in there, mathematical proofs and mathematical flavor. So vectors and complex numbers is largely the same as high school stuff. Integral calculus is again largely high school stuff. This is techniques for modeling, they call it, but this is basically the algebra here and a bit more calculus, again, probably with more mathematical things in there, L'Hopital's Linus continuity, more mathematical formats. And they've got, again, differential equations there. This is, again, a strange one. This is nothing much more than eight probability in stats here. And I don't consider this a serious stationist because it uses Excel. But there are some things, for example, there were ideas here in discrete of logic and proof and all this of it, which again is slightly different from what you'd expect in high school. And there's this 1830 that's required for the master's degree, and this is more discrete mathematics, more probability here, a bit more there than available in high school again. Some ideas of trees and graphs here. UQ, from what I put together, Marco could correct me here. I found this Bachelor of Maths with an 8 of 92 here. And again, they have choices with the same material, but a bit more advanced in the 1051 compared to 1071, and so on with 1052 and 1072. And then got this maths 1061 and the stats as well. And the 1051 here, again, linear algebra is part of it here. They've got some calculus, which is mainly high school calculus, but again, a bit more nuances there. There would be seen things like, for example, L'Hopital's Taylor series or sequences and series. Then 51 here is 71 is different from 51 again, mainly in depth. And the grid over here. So there's more details here what it actually covers here. Basically in the algebra here, all the kinds of things you expect to see. There's a bit more here on fields and sequences and limits that you would not see in the really first year courses as well. Multivariate calculus, the ODEs, nothing non-standard from first year calculus courses. This is more advanced, and it again differs from the 1052 in the material and the depth. So arc length, for example, here, and the calculus of 2, 3 variables only is. You can take this concurrently, some of them in the combinations you find. 1061 is again more discrete mathematics with the proofs and ideas, logic, graph, theory relations, those kinds of things that you would find in many courses, but not many in first year. This is advanced analysis of scientific data. So this is really more probability and stats ideas here, which is actually, I think, a pretty solid unit in maths and stats, in stats. It covers even things like log linear model, statistic regression here, which is not in many first year courses, categorical analysis, again, not in many first year courses. Adelaide, 80 of 80 here. Then got these 3 first year core units that are required for the degree there. Basic idea, univariate calculus is a degree of 80 here, linear algebra, vector subspaces, linear algebra parts there, nothing much to do there. ODE sequence and series and power series, calculus of 2 variables, mainly more linear algebra there as well. The stats is the usual first year, first level stats, which is inferences and regressions and all those kinds of things. Our university, well, quite a smorgasbord there. You've got the Bachelor of Mathematics as the old maths degree, 80 of 75. We introduced a new one that started this year, 80 of 90. And you've got the usual Bachelor of Philosophy, which is 80 of 98 there. And there's a Bachelor of Stats as well, which is 80 of 5, which is not true. It's more an 80 of 80 of 75, usual 80 there. So these 4 degrees have the same core units. You've got 1011, which is essentially multivariate calculus to start off with. The initial parts of that, with partial derivatives, all the rest of it. Then I've got the next one, which is 1012. And the thing with 1012 is, people will tell you for I said, there's some problems I'll get to later on with the ideas of how this is taught in my university here. Now, 1012 is a maths theory and methods. And this deals mainly with linear algebra, but then there's also ideas of calculus there, improper integrals, all those kinds of things. It also has ODEs in there, differential equations, and then there's a hodgepodge of things like Fourier series and Laplace transforms in there, which are there mainly to please engineers and physicists. Now, this is common to the Bachelor of Science in Mathematics and also the Bachelor of Mathematics. But this couple of new units have come up from this year, which is 1013, which is essentially nothing much more than the one variable calculus, but looking at it in more detail, more mathematical, much more mathematical. This is taught with all the full mathematical nuances and very much more rigorously. Things like, for example, the rationality of pi and e, you would not see in many courses in first year at least. 1014 is the same as linear algebra, but much more detailed, much more mathematical. So you'll be able to see here theorems and proofs and those kinds of things, not just methodology. This stats is a bit of a worry for me because this was a good stats unit, but since data science is becoming more popular, and data science actually was started in the school of, in the Department of Computer Science, and students come in there with very low level of mathematics. There's no requirement for almost any mathematics there. There's not much that can be taught there. So this was changed over the last few years to make it less mathematical. So there's either bootstrapping and more computational stuff there with Python or whatever versus coming in there. That's one option for the stats people or students who want to major stats. Then there's this 1520, which is essentially business stats. This is a more thorough stats unit, which methodology in there, more mathematics there as well. And so the option is either the first 1400 or this one can be taken by students. Now, here's a summary of the whole lot. And this is rather deceptive. So at least the eta part is accurate enough. But as far as the 1D calculus is concerned, the small y means that it's done, but not to the full extent. It's not fully first year Winnie calculus. It has aspects of it. So I think Melbourne and my university has some of this. The other ones actually seem to cover 1D calculus quite thoroughly. 3D calculus is in all the universities, except Monash and Adelaide. And then the algebra, of course, is everywhere as well. And there's some other extra bits and pieces as well. Now, there are some issues with this. Mainly the issue, at least in my university, is that when our new degree was put together, now getting back about 10 years or so, the person in charge of that was told to go and speak to all the other client departments, so they were the physics engineers in particular. And of course, you go to engineers and physicists to work out what you should teach in first year level in 2 units to come back with something that's actually worth about 6 units. You cut them down, and this is why you get things like Laplace transforms and Fourier transforms in this calculus unit, which is just tacked on with no reason at all. I think there is some application, at least with the Laplace transforms, to solve the differential equations. But Fourier transforms is no application in the math side, at least. The engineers wanted it, of course, especially electrical engineers use that quite a lot for their signal processing and analysis. That's why they wanted the thing in there. But the problem is, when I was to do engineering myself, this was taught by the engineers themselves in first year. In their signals processing, they taught the thing too was not very hard. It's just basic integration stuff to start off with. And so that wasn't at all difficult to teach in there in the few lectures. So this seemed a problem. And of course, because these units, the two major, the core calculus units we have, also taught to physicists and engineers. Engineers, we know by and large, don't care about proofs, theorems, they just want how you do things. Physicists may care to some extent about these things. So in my opinion, and the same may be true of other universities as well, and I can be enlightened there, if you've got units common to the maths majors, as well as the engineers and other places, it compromises in how you teach it and what you teach as well. So that means that while you might think I've got a strong maths degree or a strong maths in there, it's not that much, it's not as strong after all. So just the content doesn't tell you exactly what your degree covers and what level your students will get to as far as mathematical nuances are concerned. Excuse me. That's one problem I have. And in my opinion, it's at least in my university they've tried this to put 2 extra units in the maths degree for the maths majors so that we can cover some of the shortcomings that are present in the other units. and make it more mathematically rigorous and at least take students to a high level. And I've complained about this in many places, in my university and other places as well, that we take a lot of students these days in universities, and we all know, I'm not being unkind here, I hope, that we take a range of students, maybe the bottom shouldn't even be there. And because you've got such a range of students, you can be able to teach somewhere in the middle to make it accessible to the whole lot. Which means that you compromise on what you can do. And I've said over and over to my university that what we've got to do is take the very top and treat them differently, and you can challenge them and you can take them places. Those are the students who will change the world in their own disciplines. Not all students will, but you require some to do that. And of course, it always comes back to the same thing, resources. We don't have resources. I don't think it takes much more resources. I think it takes more of it. The idea is not of we can't do it because of resources. The idea should be how can we do it? That's my important message this here. So as I was saying here, there are differences. First of all, you may look about the same, but there are differences in level across the universities, and especially if they're shared with engineers and sciences, then you'll be compromised. Engineers by and large don't care about proofs. Now, it'd be nice to get people to work with me in this one, because as I said earlier, I have found stuff on the web which you will know your degrees more intimately. And I reckon there's a good paper here used to work on this together and get information out there to see how our degrees compare, not just first year level, but the entire degree. Because what I've seen so far is, you look at what the offerings are by the universities in the maths and stats, you find some offer very few maths and stats units. Our university went the Melbourne model a few years ago, and that was a total disaster in my opinion. Now they're trying to roll them back. You see, when they make a decision at the high level with that consulting staff or going against staff wishes, it takes them a long time to agree or decide that they made a mistake. They will not do that. They'll take them some other, other ways to try and improve this. So at last they try to roll back things a little bit. But because of that, in a third year, for example, there was a total of 6 units only across maths, pure, applied, and stats. There are 2 in pure, 2 in stats, and 2 in applied. And in the beginning, the rule was the students would take 2 pure to applied, or 2 pure to stats, or 2 applied to stats. And luckily, for half a year, I was the program chair, and the university was looking at the first year division of these rules. And my point was, what constrained them? Said to take only 4, and they agreed with that. But still, there were only 6 units, and 6 units to me doesn't make a degree in maths and stats. For example, when I did my degree in engineering, I did a full course in complex analysis. Our maths degree had half a course in complex analysis. The other half was having to do with either algebra or functional analysis, whatever. When I did my degree in mathematics, I did 4 units in analysis, 2 in undergrad, 2 in third year, and 2 in fourth year. In fact, there's a second year one as well that I didn't do because I came through some other channel. And in my stats major, essentially, there were 8 units at the stats major in third year. I did all 8. And now we have hardly 2 or so. It's changing slowly, so some of the changes are slow. Anyway, it'd be nice to be able to collaborate with others in this area and see how they can compare the entire maths degree structure throughout Australia to see where the differences really are. Because I think it's important, as we've been hearing throughout this sessions here so far, it's not that maths is important for your discipline. It's what other skills maths teaches you. What we try and tend to say is, I keep telling the students, don't forget the content, but you won't forget the thinking that goes behind it. It's mathematical thinking is important because that's where it comes in problem solving, and that's where it's useful in all disciplines. That's what I have. Thank you.